Right, hello and welcome to another episode of our Links Digital online series. And today we'll be looking at another image processing method to find certain background images and effects. So today we'll be looking at the background subtraction method, and this is commonly used to generate a foreground mask and to track moving objects within a certain frame. So we'll be looking at how it could possibly track vehicles or lane lines that are changing using this simple method over here. Right, so after maybe this or next few sessions, we'll be looking at trying to combine these methods that we have done, try to permutate within the different filters and image processing in order to gather data that we can use for a vehicle to track where it's going, as well as to help it to achieve autonomy. Right, so we'll look at this, and what we're going to do, as the name suggests, this background subtraction will calculate the foreground mask and also perform a subtraction between the current frame and the background frame. So what it will do is it will compare, and the static part will be in dark color, and those moving items will be highlighted in white, or at least a lighter color. Right, so let's go into the code. Alright, so for the code, after capture, so video capture, we have to include this thing called foreground background. So we just call it foreback. So it's the foreground background. So we use a method in CV2 called BGSEGM. And then we call create background. Subtract. So it's just an empty function, and then after that we'll go into our loop, and then we'll add. We don't need to use the grayscale frame for this. The first we'll pass in the foreground mask, and that will use the fallback method. So we paste here fallback dot apply, and it'll take in one argument, which is the frame that we want to apply on. Right. After that, we'll just scale it, and it will do what it's supposed to do. So later we'll look at what else we can call within this function, but for now, that's what we will try to apply. This is alright. So instead of scaling the frame, we'll be scaling the foreground mask instead. So the mask is the output itself. And let's run the program and see what we get for this. Right, so as you can see from this, there's all the moving objects in the background are in white. So if the program feels that it is something that is moving, the foreground is highlighted in white, and those that are dark are those that are static, non-moving. So we can see that the vehicles are the ones that are really highlighted quite clearly. From this black and white image, you can roughly tell where are the vehicles, as well as the lane lines are also pretty well distinct. So as we can approach the zebra crossing, it's quite obvious that it's black and white, really distinct, and the lane lines look quite obvious too. So this is something that we can use in future when we try to combine and detect the lane lines, the curvature and all. Right, so let's move on, and we can use something called the morphology mask. So we can create another one called morph mask, and this will take in another argument, which is first we call the method from CV2 morphology x, like this, and then we'll pass in the first mask, then CV2 dot morph open, and lastly is the kernel. So on top here, we have to create another variable called kernel, CV2 dot get string element create the morph image. Then we pass in the kernel, say 33, and we'll just put this on top of that. Right, so here with the morph mask, and we can paste in the mask. And let's take a look at how it turns out. Run the module. Let's just do a quick comparison with the one that we had initially. This is the foreground mask, this is the morphed mask. So let's just observe the differences. Right, so as you can see, the vehicle still is moving. You can roughly tell just by visuals, and the lane lines are quite pronounced on both sides. One thing is that the leaves lose a bit of the detail here because of the size of the kernel. So if you want to lose certain white eye patches which are not critical, not crucial to the project, or at least they're not the things that you are looking to identify, they always increase the kernel size. So let's try 5 now. So you can see over here, it lose even more detail, which is not always a bad thing because we still retain most of the lane lines and all the detail we need. But then again, we kind of lose this line over here. Look at the pronounced lines here compared to over here. So I think masking is something that we'll be looking at, and how we can look at a region of interest and phase out the rest of the so-called noise, which is this salt and pepper kind of background that we don't want to see. So this is one technique that we'll be using later on. We'll try and see whether this is the best, or we'll apply different filters along the way to make the image that we want more pronounced. So that's it for today's session. And next we'll be looking at masking with colors. Right. So that's about it for today. If you're looking for the code for today's session, you can find them in the comments below. And if not, see you next time.